Hello friends, I am GK Kate. Let's see today's topic is that determination of difference in elevation by single observation. This part is belongs with trigonometrical leveling and which is related for only single observations. Okay, these single observations are these single observations are taken from between 2 points P and Q. Okay, so determining that difference in elevation can be determined by either by single observations which is made from one station or by reciprocal observations. Okay, and that observations can be corrected, or that single observations may be corrected in the following cases. These corrections applied in single observations like correction for curvature, correction for refraction, and axis signal correction. So that determination of difference in elevation by single observation having three cases. Let's see what about first case is that angle of elevation. Let's see this diagram. This diagram having that P and Q station. Okay, so that P having that angle of elevation which is that alpha, observed angle of elevation from P to Q. Q is that top of object. Okay, then P1 is that horizontal distance between that particular 2 points. Then R related that refraction correction. Then half of theta is that curvature effect. Okay, H is that QP1 which is difference in elevation from P to Q. Okay, and major important is that alpha 1 is that observed angle corrected for axis signal correction. Okay, so from this terminology we have to found that difference in elevation in single observation for case of angle of elevation. Let's see one by one. This P to A is that horizontal line, P to Q is that object and that instrument axis. Okay, so this must be that line of level line, this also level line. Okay, this is H is that QP1, that height of or difference in elevation from Q to P1. Okay, let's see start for that axis signal correction which is from observe angle corrected for axis signal correction, which will be previously found in that axis signal correction was alpha 1 is equals to alpha minus delta 1. So angle of elevation that correction will be subtractive. Okay, similar equation can be rewrite in this form: alpha 1 is equals to s2 minus h1 divided by d sine 1 seconds. Okay, which is equation 1. Same equation can be alternatively write here: alpha 1 is equals to alpha minus tan inverse into bracket s2 minus h1 into cos square alpha divided by d. This is equation number 2. Then let's see here that P1 is that horizontal distance. Okay, so that PA is that horizontal line, so it must be congruent with that arc PP1 which is congruent also chord PP1. Okay, so arc and chord will be get as a horizontal line and will be considered as a completely d or horizontal distance. Okay, in between that, for this particular angle subtended by the earth which is theta. Okay, and can be found by this triangle also POP1, which will be that 90 minus half of theta. Okay, this will be theta and then it will be get that 180 minus something. So out of that we have to consider only PQ P1, either P1 PQ. That triangle belongs with our part of today's angle of elevation. Okay, so from that horizontal distance you can again see here that is angle found by P1 PQ which is equals to Rm theta. Okay, where is P1 PQ? P1 PQ which is that R. Okay, which is m theta. Then H is equals to QP1. H is equals to QP1, difference in elevation between PQ. Okay, then let's see triangle PQP1. You have to found that particular angles. Okay, for angle QPP1, okay, totally angle was found by P dash PA minus P dash PQ plus APP1. Okay, let's see here. This will be written as alpha 1 minus m theta. M theta is that refraction angle is equals to r plus curvature effect half of theta. Okay, then P1Q. Let's see here. Where is P1 that Q? Okay, P1Q, which will be that P1Q is equals to that 90 minus half of theta plus curvature effect plus this angle subtended by earth. Okay, which will be automatically getting it reduces as 90 plus half theta. Then angle PQP1, PQP1, this angle. Okay, so this angle will be that automatically this angle addition that 180 minus both of them. So we can write here 180 minus this both of angle, 180 minus this in bracket alpha 1 minus m theta plus half theta bracket complete minus 90 plus half theta, this one. So this PQP1 will get 90 minus in bracket alpha 1 minus m theta plus theta. Okay, then from this angular angles, okay, by sine law we can write here, which will be this QP1 divided by sine of QPP1 is equals to PP1 divided by sine of PQP1. So QP1 is nothing but that horizontal distance divided by sine of that particular angle QPP1 is equals to PP1 must be that horizontal distance divided by sine of that particular angle PQP1. Okay, so this equation automatically when you found in terms of H is equals to D is equals to sine into bracket alpha 1 minus m theta plus half theta bracket complete divided by cos of into bracket alpha 1 minus m theta plus theta bracket complete. So this will be equation number 3, and this is exact equation of angle of elevation. Okay, same equation can be written in the other forms, also be written as H is equals to D into sine into bracket alpha 1 minus m into D divided by r sine 1 seconds plus D divided by 2 times r sine 1 seconds bracket complete divided by cos of into bracket alpha 1 minus m into D divided by r sine 1 seconds plus D divided by r sine 1 seconds. Let's see here what would we write that theta and their effect. Okay, let's see here. From the correction for curvature and refraction, you can be right here r is equals to m theta. So theta can be written as d divided by r into radians. Okay, so that nothing but 1 radians is equals to 2,06,025 seconds. So must be that d is equals to r is equals to m into d divided by r sine 1 seconds. Okay, so it could be that let's be that is a effect of changing that equation, so radian to seconds. So 1 radians must be that 2,06,265 seconds. It is conversion. So same you can written as the expression in terms of that radian to seconds. Okay, then same equation can be you can write as reducing these terms as the h is equals to d into sine into bracket alpha 1 plus into bracket 1 minus 2am bracket complete into d divided by 2 times r sine 1 seconds bracket complete divided by cos of into bracket alpha 1 plus into bracket again 1 minus m into d divided by r sine 1 seconds bracket complete. This is equation number 4, which will be getting that radian to seconds. Okay, then what about approximate equation or approximate expression? So this approximate expression obtained as taking angle P1Q as a 90 degree for small angles of theta. Let's see here diagram. What about angle P1Q? P1Q. Okay, so this is that smaller angles are taking that approximately 90. Okay, for these small angles. When you taking this P1Q as a 90, then this expression can be changes like that. What about that PQP1, which is equals to 180 minus angle QPP1 minus 90? That means 90 minus alpha 1 into is equals to 90 minus bracket alpha 1 minus m theta plus half theta bracket complete. Then again same one, which is equations can be found by sine law, and putting in this form, that is QP1 is equals to h divided by sine into that QP1 angle, which is the alpha 1 minus m theta plus half theta, is equals to P1, that is horizontal distance, divided by sine into bracket PQ1, that should be 90 minus into bracket alpha 1 minus m theta plus half of theta bracket complete double bracket. Okay, so same such equation can be written in this form. H is equals to, or reduces that same equation above, reduces that h is equals to d into 10 bracket alpha 1 minus m theta plus half theta. Okay, so again this equation can be written in the form of that radian to seconds, or that theta is equals to d upon r, that radians. Okay, and will be converted into that along this form. So this will be that getting h is equals to d, final equation, h is equals to d into 10 into bracket alpha 1 plus into bracket 1 minus 2m bracket complete into d divided by 2 times r sine 1 seconds bracket complete. So this is fifth equation, is that approximate equation. Let's see here that equation number 3, which will be that exact equation of angle of elevation. Okay, so you can use this equation for finding that difference in elevation of that particular object as QP1, okay, from P to Q. Okay, and this equation number 5 can be used for this approximate equation for angle of elevation when theta is small considered and that angle P1Q as 90. Okay, so this is the part of today's part of determination of difference in elevation by single observation, which is having first case is that angle of elevation. So let friends, this is most useful for finding that difference in elevation in case of single observation. Okay, thank you friends.